move into the eval side of stuff. So it will be basically the logical flow. We speak about the model, then we speak about how we evaluate the model and how evaluation can benefit people who have been building the model. But Quinn is probably way better than me at explaining all of this. Then we will have some demos and we will be back at the most important part of some events, the networking. So it was a great pleasure. My name is Thibaut. If you want, because my actual name is Thibaut, which is kind of a weird, shitty French name. And so at the age of AI, I rebranded myself Thibaut, which is a bit more. And I like to say I'm the only human pretending to be a bot. Usually bots pretend to be human. I'm trying to do the opposite. And I'm the founder of the Voice AI Space.com, which is a free and open library where we try to centralize as much information about the voice ecosystem. So you will find products, news, knowledge, jobs, and events. Okay, all of this for free, and we do events mainly in Europe. So it's the first time for me in the US. So thank you to like all of you. So now I stop, and Jagadish will explain to you what they do at NVIDIA.
So hello all. My name is okay, should stand here. Jagadish Balam. I lead speech research at NVIDIA. If you've heard of Parakeet, Canary, Sort Former, Magpie. Right here? That's good. I don't block this. Okay. Okay. But do we have a clicker? No. Right here. This is good? Okay. Yes. It's all for you. Okay. So Parakeet, Sort Farmer, Canary, Magpie DTS. Hello. Sorry. Magpie DTS, this is all these models were from this team. And that's at least 3 models for your bingo card. If you want a sticker, it's here. So today I'll be talking about Nemotron ASR streaming model, one of the latest ASR models that we released. So why did we build this model? If you're in the speech space, you know that in the last 1 year, all the work has been concentrated towards voice agents. So if you talk about voice agents, one question that keeps coming up is, what's the most optimal technology out there? Is it half duplex, full duplex? Our view of this is that right now both have their strengths. The full duplex, we are seeing evidence that they're very good at low latency, turn taking, and more naturalness in general. But if you want quick scalability, more compliant voice agent, you would rather stick with the cascaded systems, which are half duplex. But what both the systems need is a good streaming speech model. And that's what we're going to talk about today. Privacy would still be from the offline models. Yeah. That's something we are working on right now, a profitable ASR model. This particular model, I know of use cases where some users have fine-tuned the model to redact the PII information and it works. So if you have a data set, with all the PII information blanked out, the model learns. You have to fine tune it. Though. We haven't done that. Yeah. Yeah. Oh, it's on. It's back. Okay. Okay. There was another question. Sorry. No.
Yeah, yeah. One last question, maybe.
Yeah.
Yeah, so I guess given your focus on voice agents, do you have any plans to train any models that take in more than just the user audio as context and kind of take in the full conversation history to help with transcription accuracy?
Exactly what we are working on right now. 2 to 3 months, you'll see something. Yeah.
I love the work that the NVIDIA models team is doing. It's been so exciting to have open weights and open source and open data tooling that is really progressing very fast. You're on the panel,
Okay.
so you could have a seat. We also have Fabian and Brian, so we have 2 other people on the panel. Pick your chair wherever you want to be, and we'll make sure we're in the live stream. There, you sit here, I'll sit on you. First, we're going to just have each of you introduce yourselves because you can introduce yourselves way more excitingly than I can. So let's start with Brian.
Great, thanks.
Yeah. I know we're not we fell down on the theater, setup job. But we have good audio.
Can you hear me? Great. My name is Brian Johnson. I am staff engineer at Tavis, and I work on conversational AI. It's audio video. Thanks for having me.
Hey everyone, my name is Fabian. I'm one of the co-founders of AI Acoustics. We train audio and intelligence models for voice agents, especially. We sit between the telephony layer and subsequent ASR or voice activity detection to single out the main and primary speaker and to not have any disturbances like noise or reverb or background speakers that can derail your voice agent.
Do you want to introduce yourself again, or you think?
If the room wants me to. Yeah, I think I'm good.
So my first question for I'm Quinn. Most of you know me. I come from a company called Daily that makes real-time audio and video network infrastructure, and I work on open source framework called Pipecat that a lot of folks in this room use. My first question is, there's been really, really amazing progress in multimodal models of all kinds, especially speech models in the last couple of years. I am curious what those of you who are training models every day think are the solved problems recently, and what are you thinking most about that are the unsolved problems?
Yeah. Solve problems. I think right now, if you have abundant data and you know how to label it, those problems are solved, obviously. ASR we thought was solved, but voice agents have brought in their own problems with transcribing email addresses in general, names, and all those kinds of things. So models have to learn to keep context of the conversation, corrections of the user, and the LLMs themselves are not great at picking important context. So these are some things that we are learning how to teach the models, and hopefully we'll have them soon.
We hear that a lot from people building production voice agents, that there are a lot of paper cuts around ASR recognition. Like, it's incredible most of the time, and then there are these spikes that really matter for production agents where you need more data or you need something.
Yeah, we mostly work on the audio input side of things, and our models are trained on this as well. So what we often see is that voice agent builders train or develop their model or test even their model sort of like in a lab kind of environment, in an office or in like a one of these telephone boxes and something, and then they should work in the real world, and that's often acoustically very, very messy. One of our partners that we work with, for example, builds a voice agent for like drive-through, and you can imagine in a drive-through, well, it's a very different scenario than at home or in your office. So that voice agent will likely going to fail. So there's still quite a gap or a mismatch between how do I build it, in which conditions, especially on the audio input side, and where is it actually deployed then. And I think this is where we will see more and more also like testing and eval around it at some point.
I mean, the real world is so messy. There was a whole early generation of voice agent deployments at scale where a lot of our customers learned that people don't turn off the TV or the radio when they call the customer support line, because they don't need to when they're talking to a person. But unless you can distinguish between background speech and the speech of the human that you actually want the LLM to be talking to, you have a bunch of problems.
Yeah, that's one of the main issues we see as well. Yeah.
Brian.
Yeah, so I thought about this a little bit, and the one thing I think is solved is latency. And I know that we need to get to like 10 millisecond response time, but people take time to think. It takes us 700 milliseconds to think. And I think our pipelines are fast enough to do that. The thing that I think is missing is the sort of architecture around queuing up what to talk about next, figuring out what to say first, how to say it, understanding the context of the conversation, not just in terms of the content, but also in terms of the emotional tone. And so I feel like we're really, really early. Like, I think latency is there, but like everything else is kind of exciting. But when I put it in front of someone who isn't in this space, I think that it's very jarring for a lot of people still.
You've given some great presentations on sort of all of the different things that you feel like the models can do, and like little bits and pieces of glimpses of the future. We'll come back to some of that. I agree with you that latency is a solved problem from a technical perspective, and probably most people in this room feel like they know how to build low latency pipelines. I will say that I meet with a lot of enterprises trying to build voice agents who end up with 4, 5, 6 seconds voice to voice latency. Once you are starting without necessarily all of the sort of the best practices knowledge, and then you layer on a bunch of things like compliance guardrails that your IT team wants you to add, it's not a solved problem from a helping people get deployed perspective, but I do feel like latency is a solved problem from a core technology perspective.
I will say, like, in practice, latency, we aren't seeing voice AI or video AI that responds as fast as we want to. I think it's more of an infrastructure problem, an architecture problem, than it is a model or a compute problem. And I just don't think we need to have the AI thinking ahead of time. We need to have it considering things while people are talking. So I suppose that's not even solved. Yeah.
No, that's a good point. Fabian, you have a job title that's something like audio destroyer. Can you tell us about that?
Yeah, that's true. I told you yesterday about this. So how we train our models is basically we have a large data set of really high quality audio data, and then we decided for an approach to not sort of like collect all the real world data out in the wild, but for like a more simulation approach. So a few people on our team, their job description is they're audio destroyers, so to say, professionally, and they write all the simulations kind of how do I realistically add we have more than 1,000 types of like categorized noises. Basically, we can place people in the room in different like room geometries and with different like reflection patterns. Also like overlapping speakers, of course, some in the background, some side speech. So all the basically analog part or the acoustic part from the sound wave leaves me and then goes into a microphone. Then we simulate all the different microphone frequency responses and how this can react. And then on the digital side, there's a lot of like digital signal processing that happens, WebRTC processing, and we basically have to think about what happens to an audio between a speaker all the way until sort of like it hits the voice agent, basically, so the voice activity detection or the ASR system or speech-to-speech model. And we invest a lot of time and money and man and women power into, well, yeah, simulating all these different artifacts. And we have a few people in data engineering that who destroy audio professionally.
I mean, I'm lucky I get to talk to most of the teams that are training audio and LLM models. And a year or so ago, people were still saying to me very proudly, we train all our models on studio quality recorded data. And I was like, don't do that, because by the time my tooling gets done with that audio, the Opus audio encoder has not made it studio quality anymore, unless, I mean, you can, but you don't generally want to because of network bandwidth issues.
Yeah, and well, a podcast is a very artificial audio product, right? It went through a lot of like audio engineering, and I don't know who's ever been on a phone call or like have seen real audio. It doesn't sound like a podcast. It's just like a man-made sort of like artificial product, how we like to listen to music, and also this is how it sounds nice to the human ear. We have made also the experience that optimizing an audio for perceptual human hearing is not very helpful always for machine input. So we have retrained basically our machine learning models in a way that it's helpful for an ASR input or VAD, but sometimes if you optimize for, again, perceptual hearing, means that you strip away too many auditory cues, or you make the audio like too dry, or basically remove too many of the frequencies that are helpful for, again, ASR, such things. So yeah, optimizing for human perception is not very helpful for voice agents.
Actually, that's a great question for Jagadish. I often find there are audio regimes where I cannot understand the audio, where the ASR does great. And the opposite is sometimes true. How do you deal with that when you're building the data sets and, you know, evaling as well the models?
I mean, eval is we try to collect close to the evaluation domain, data sets that are close to the evaluation domain. Eval is, I think, because of the scale, is an easier problem. Even some of the customers and users are able to share some of their use cases. Simulation is hard to scale up. There are so many different ways you can simulate the distortions into your audio, and human bias always comes in, so you cannot really make it that realistic. This is one of the unsolved problems in speech. We really don't know how to simulate real conditions. Otherwise our models would have all been done by now, right? So
Last question, we'll wrap up with Brian. So you at Tavis build like what I think of as truly full stack models and systems that are multimodal in and out in audio, video, text, plus a whole bunch of signals like emotion. How do you think when you're, and you guys both train models to do that, and also you build the engineering of the sort of way the models share information behind an API so that the rest of us can use this stuff. How do you think about what you try to train into one model, multiple modalities or multiple signals or whatever, versus what you do, what is better to do with separate smaller models that you kind of stitch together?
Yeah, that's a good question. We kind of talked about this a little bit before. So I think the word I used for that was tension. And tension creates structure. So in the current space, we talked about data, and the data is kind of missing. We can't create synthetic data that models human conversation that's good enough or realistic enough. If we could, we'd have the models already. And finding enough good quality data, conversational data that's natural, that's in the right environment, I haven't seen any that's actually particularly good yet. And so for now, we are in a situation where we need to use heuristics to develop small models. The way I think about it is we have to kind of shoot for the moon and try to build the big model. So we create small, highly curated, really high quality data sets to build the big autoregressive models. And then we also work on heuristic-based smaller models that we bring together to try to raise the floor of what we're delivering to our customers, so that then we can learn what it takes to build a good conversational model. Because a lot of this is about intuition. A lot of this is about how do you understand how people communicate with each other. And I personally, in this journey over the last 2 years, have become a better conversationalist. It's not by much, but it's definitely gotten better. And so I think that tension, I think we still have to work on that. I feel that there's still a big divide between the big model and the small model. And so at Tavis, I spend a lot of time giving the the research team a little bit of a hard time, saying, why don't we come together? Why don't we take that big model, take a small piece of that, ship it. Let's get a flywheel going. So we can learn, and we'll keep working on those big models, but you've got to look at what you don't have and start to identify what we can give you by building a small model.
That's great. Thank you all.
Yeah, thanks.
All the panelists will be around. Come find them. They're all fascinating to talk to.
Great. Hi, everyone. I'm George. I'm one of the co-founders at Artificial Analysis. Very quickly, so we're an independent AI benchmarking company. We benchmark across language models for their intelligence. We benchmark inference providers, and we also benchmark other modalities, including speech, image, video, and always more coming. In terms of how we benchmark speech, we benchmark across speech-to-text models, text-to-speech models, and speech-to-speech models. We use a mix of great open source data sets and benchmarks out there that others have created. We also contribute back to open source, and we create our own benchmarks as well. So in speech-to-text, we're really excited about our new AA Agent Talk ASR word error rate benchmark. In speech to text to speech, we have an arena, and in speech to speech, we benchmark with our Big Bench audio benchmark that we released, and we also use great open source benchmarks out there for Duplex Bench and Tau Voice. Today, I'll be talking about the kind of exciting hot new area, speech to speech. And we've put together a chart here of progress across these three modalities. So speech to text, and text to speech. And here we have kind of a normalized score. Don't think about it too much, but it represents progress in quality of the leading model in this modality. And on the x-axis, we have release date. And what we can see here is that there's a long storied history around speech to text and text to speech. But coming on the scene in terms of usable speech to speech models, it's only recently. And that's not to say, though, that we're as far off, because progress has been really fast and really supported actually by historic progress in speech to text and text to speech, as well as, of course, language models. We released Big Bench Audio in the first half of 2024. It's our speech reasoning benchmark. And we'd say it's one of the first, or the first benchmark to test frontier speech reasoning capabilities. It tests speech-to-speech models to answer hard questions. And so it's not just about their ability to talk back to you, but can they provide intelligence and offer intelligence when speaking to them? There's been fast progress here, and it's in around 2 years, the benchmark's kind of approaching saturation, which speaks to how fast progress has been. When we look at open weights performance on Big Bench Audio, credit to NVIDIA for releasing their Nemotron voice chat model, which is the best performing open weights model on Big Bench Audio. But there are also kind of great other releases from others. But I think what's exciting about the speech-to-speech benchmarking landscape is that it's evolving really quickly, and I think we're getting a lot more mature in terms of how we think about the performance of speech-to-speech models, particularly in the speech landscape where it's about interacting with humans more than I think significantly more than the language model landscape, which is often involved. The output is kind of code execution that makes a document. Or it's speaking to other agents and systems to make tasks. Speech to speech is really about humans. And so it makes sense not just to think about benchmarks like we do language models, but to consider other aspects of speech to speech model performance. And so I think a benchmark that we have added to artificial analysis, our kind of benchmarking website, is benchmarking conversational dynamics. And here we use the full duplex benchmark. And what this benchmark tests is aspects of using speech-to-speech models that humans experience. So pause handling, turn taking, interruption handling, and kind of back channel handling. I think these aspects of speech-to-speech model performance are really as intelligent or up there with the raw intelligence, the horsepower of these speech-to-speech models. And so we think thinking about speech-to-speech models you need to take a broader approach. And so I think conversational dynamics is really critical to think about in terms of a speech-to-speech model being used in production. I think one point, though, is that kind of speech-to-speech models, they've made fast progress if we think about that line going up very fast, but there's still there's jagged frontiers within speech, and particularly in terms of conversational dynamics. So kind of pause handling, turn taking are more mature, but there's other aspects like user interruption handling and back channel handling that there's still a lot of progress to be made. And I think we're going to be monitoring particularly some of these aspects quite closely and publishing results, of course, on artificial analysis to analyze that progress and showcase it. Another aspect of speech-to-speech model capabilities is conversational dynamics. So I mean, the ability to converse with others. It's like native, of course, to speech-to-speach, and also, of course, tool calling. And we've seen this capability increase particularly quickly. We're seeing voice agents come online that are able to call tools to take actions. And the benchmark that we really love here is Tau Voice. And we use this to benchmark agentic performance of speech-to-speech models. Would also love to call out Eva by ServiceNow is another great benchmark in this space and another one to watch. And in terms of performance of models here, I think there's still a way to go for the open source or open weights speech community in terms of tool calling. So it's not really supported by the open weights models out there. And so that's why these models are all proprietary. But I think in this domain, we're also seeing fast progress. So Grok Voice Think Fast 1.0. Some companies are better at naming than others. Has already achieved 52% in this benchmark. When released, I think the leading score was GPT or Real-Time 1.5 at 39%. And I think this is something that I think we're going to see mature quickly because it's really supported by progress in language model tool calling. And so I think this is a benchmark that I think you should monitor. If you're thinking, maybe you might be using a pipeline approach now and you're analyzing, okay, can my agent move to speech? I think Tau Voice is the benchmark to watch, and I think the fast progress is really exciting and promising. I think lastly, as we think about speech-to-speech benchmarks, a few capabilities that we'd love to see kind of fast progress on. We're thinking about it. We'd love other people to also think about it. Is across these 4 aspects. Sorry, 5 aspects. So I think there's a long way to go in terms of speech-to-speech capabilities across multilingual performance. Speech, more than other modalities across AI, is kind of driven by data, and you do need like a lot more variance in the data. Some capabilities in speech-to-speech don't generalize as they do for language models, and so I think multilingual performance still has a long way to go, and we'd love to benchmark that. Steerability and instruction following, safety and alignment, particularly thinking about speech is all about interaction with humans. Audio understanding beyond speech, so handling of other sounds, and then more than just the words, emotion, intonation also still has a long way to go, and there's a bit of a lack of benchmarks out there around this. And then robustness and consistency. I think a lot of you out there building voice agents, I'm sure, have experienced this. But there's a long way to go in terms of getting consistent actions or consistent experiences around voice agents. So I think some of the aspects that aren't solved out there, like emails, sometimes they work. Names, sometimes they work. Tool calling also still has a long way to go with this respect. And so we'd love to see benchmarks out there that monitor these. And then these are the things that we're thinking about as we look to add new benchmarks to artificial analysis and as we look to develop new benchmarks ourselves. So thanks very much. And one last thing is, like, we're hiring, so please come chat if you're interested in speech benchmarks. Thanks very much.
And you're on the panel, so pick your seat. And everybody else, you know who you are on the panel, please come on up. Do we need that one? Yeah. Okay. I'll be on the end. Oh. You sit. Yeah. I will stand very casually. I hope so, because I've been yelling at other people about being in the live stream. George, thank you. That teed up this panel great. I'm going to mostly try to ask in a bunch of interesting ways. Which way do I move over? Oh, panel, move this way. Are we good? Sort of, yeah. I'm going to try to mostly ask in a bunch of creative, interesting, and provocative ways about why evals that are good are so hard to build. So if I fumble any question, just answer that question. But first, let's go down the line and quickly introduce yourselves.
I'm Tara, and I'm a voice AI researcher at ServiceNow.
Good evening, everyone. Great to be here. I'm Sridhar Nemala. I'm also from ServiceNow.
Hi, I'm Jeff Boudier. I'm on the product team at Hugging Face. I work with our partners, with NVIDIA being one of our main partners.
Don't need to hear from me again.
I am Eva, and I work at NVIDIA, and I'm doing LLM evaluations.
Hello, my name is Adam. I also work at NVIDIA with Eva, also in this team, and also working on LLM evaluations.
So let's start with the service now, folks. So we pass the mic back down. As George mentioned, you all have a very sophisticated evaluation framework that you released pretty recently, about a month ago, I think. I'm a huge fan of this framework because I think the two hardest things about building good evals, at least today, I may have other answers other days, are just being super, super detail oriented about the setup and the data, because it is so easy to write an eval that does something that you don't actually think it's doing. And secondly, in our domain, building good multi-turn, because for me, the only evals that reflect what I actually do with voice agents are long multi-turn evals. And I feel like you all really put the work in there. Can you just sort of describe like why I'm sure it was an enormous amount of work. Why did you build Eva? What was top of mind for you? And did you learn anything that surprised you?
Yeah, definitely. I totally agree with everything you just said. I think that was one of the biggest surprises with working on Eva, is that we were working on sorry, other voice agent benchmarks. And we would often look at examples and we'd see like, okay, the scores are low. There's a problem. And we'd look at the metrics and basically see that it wasn't low for the reasons we thought. Like the things we thought were happening weren't the actual issues. I think that's kind of how we learned that it's very hard to focus on what the issue is. Like I think a lot of us here will have a pretty good intuitive understanding of what the challenges are with like voice and speech models. But when you put this all together in like one pipeline or one agent, to know in a given scenario what exactly went wrong, and if I could only fix one thing, what should I fix to make the biggest improvement? I think that was really the biggest challenge that we found. And because we realized how difficult it was, I think it made us really like try to be as detail oriented as possible to be able to provide those kinds of insights to people building models.
Thanks, Tara. So I will add my 2 cents. So I lead the core AI team at ServiceNow, and one of the biggest focus areas for core AI team is enterprise AI benchmarks. And when you look at enterprise AI benchmarks, there are agents and there are voice agents. Voice agents are distinctly unique. So in terms of input being messy, noisy, and real time, multi-turn, all of these. And not only all of these, we all do not have a fundamental consensus on what is a good voice agent. When we think of agent, we think of accuracy, task completion, and so on. But what is a good voice agent? So this is where when we started building EVA, evaluating voice agents as a new framework, we also started looking at fundamentally what is a good voice agent? What are the fundamental dimensions that define a good voice agent? And this is where we came up with accuracy is one dimension, but there is also a whole experience as another dimension. And again, when we are thinking about experience, people have been thinking about how natural the agent sounds and how fast, how low the latency is, and so on. But fundamentally, we introduced many more dimensions in terms of what is the cognitive load the user goes through when put through this multi-turn conversation, real-time multi-turn conversation. So this is where we introduced conciseness, conversation progression, and so on. But this is where actually, I mean, I'm really excited. I'm so happy to see the shout outs from Quinn and George for EVA. Thank you.
Let's pass the mic down, but the best panels are where people feel so invested that they grab the mic and say something. So if you want to short stop the mic, you can. But my next scripted question is for the NVIDIA team. But George, you have the mic.
Well, I'll pass it on. I'll give a big shout out to Eva. Super popular with the Hugging Face community. I think you guys announced in a blog post, got like 100 people have voted it. So super cool contribution.
A really high level question about the Nemotron project, because I'm really, really excited about the sort of open weights, open source, open data, open training tools direction, and all the investment that's going in there. You all work on the evals part of that world. How does that inform the whole big picture of what Nemotron is doing?
Yeah, I absolutely agree with you that the Nemotron is absolutely exciting project. And as you said, the main goals of this project is to be as open and as good model as possible. So, for example, as you said, we open source a lot of things. We open source data, we open source the recipes, we open source weights, but we are also the only model that open sources the evaluation recipes, so that if any of you wonder how you could reproduce the numbers that we put in model cards, you can just go to our tooling that we use for evaluations. It's called Nemo Evaluator, and it's also open source. And you just can find the evaluation recipes there and just run evaluations yourself, and you should get exactly the same numbers that we publish. So that also contributes to the openness.
And thanks, Eva, for walking through the openness part. What is also important for the Nemotron is accuracy, right? So to be accurate, we need to actually win the numbers, right? So what is important, not only to evaluate the model after it finishes training, but also while the model trains. So the evals are becoming even more important, even within the context of training itself, and they cannot be a bottleneck for performing next iterations.
Yeah, so once you train the models, you need to have a good way to evaluate them consistently and have high quality of tooling, not to waste too much time fighting with the evals, basically, but just to launch some, like for example, the Nemo Evaluator. And that's basically our job of what me and Adam, for example, are doing, to provide the reliable evaluations for the teams that are building models, so that the evals that they are generating are reproducible and as trustworthy as possible.
I use the Nemotron 3 Nano and Super models a lot, and also run all my evals on them. And I find that my opinion is that models in that 30 billion to 120 billion parameter range are sometimes incredible, and sometimes they surprise me at not being able to do something I think they should do. They're very, very spiky. I want to throw that open to the panel as a question. So I think we're all trying to figure out how to use more mid-sized models. And is it true that mid-sized models are maybe weirdly spiky, or is it just me? And if it is true, what do we do about that from an evals perspective to sort of understand how and where to use those models effectively?
So my perspective on mid-sized models and kind of why they're spiky is that it's something I think you're right, they are spiky, and it's something that's kind of driven by kind of this this wave of reinforcement learning, is allowing labs to like really focus on certain capabilities. And so that's why you get spikes in some areas and not others, rather than just general performance increase. I think it's a big driver of that. And so I think it's on us as benchmarkers all across the panel to come up with benchmarks that measure like capabilities more generally, don't allow spiking in just one area. And when we're talking about evals and thinking about like developing those evals, one kind of look at different dimensions all at once. That's something that we try and do with artificial analysis, so that we can pick up if something's spiking in one area. One number on one eval doesn't really like tell the whole story. And so I think that's like critical when thinking about evals in this space.
Maybe I can expand a little bit on that. And I think like really it depends on the use case, like which properties really matter to you. And so when you look at the aggregated sort of benchmark score, it doesn't really tell you the story, whether or not this is something that's going to work on the cell phone or with like different types of accents, different types of languages, context. Do I need to call a tool to get some knowledge from like a healthcare provider? I don't know. All these sort of properties are like really specific to your use case. And so in addition to providing general guidance via high level benchmarks, I think it's really important to do two things. One, to look at models across all these different dimensions. They will tell you how they perform on accuracy, on speed, where you can run them, and all these things. And also to sort of have your own sort of eval set, right? That's something that I think companies have learned to do with LLMs and text. It's harder to do with audio, but it is still what you need to do if you're really building technology that's going to be relying on those models.
I think that's a really good segue to come back around to ServiceNow and the EVA project. So I write a lot of 80/20 evals as I think of them, or maybe less charitably, throwaway evals. It's a completely different thing to try to write an eval that you stand behind when you put it out in public, and to be able to maintain that over a long period of time. Obviously, artificial analysis does that at a very large scale. Are you going to maintain and keep extending and adding new models as they come out to EVA? And if so, how do you kind of do that from an engineering perspective?
Yeah, so that's a great question, Quinn. So I think of in all the benchmarks, once we make a benchmark public, there will be hill climbing, there will be spikes, and that benchmark will be solved. But some of the data that George was sharing,
Is that a good thing or a bad thing?
I think that is not necessarily a bad thing. But I think some of the data that George was sharing earlier, I do not know. I mean, how many of you have noticed? A lot of the numbers were actually in 99s, hundreds, close to hundreds, and so on. But one of the last two slides he was sharing on agentic performance, the best performance was 50%. And most of them were in 20%, 25%. And that's exactly our experience, even actually when building EVA framework. The best systems we saw were doing at the best 50%, both on experience and accuracy dimension. And this is where I believe there is a huge opportunity. First, I mean, in terms of what is a good voice agent, to define that even more substantially. And two, there are many more dimensions, especially with voice, to explore, to make it difficult. It's very easy to make it difficult, especially in terms of the noise, environments, and accents, and so on. So that's my takeaway. I think, I mean, in voice, actually, these open benchmarks are good. Hill climbing on those benchmarks is good. And we will keep producing more and more benchmarks and more and more harder scenarios, which, again, the models will improve on those.
Plenty of work to do on evals.
Yeah, I think a similar thing I think about there is often that you can always calibrate your thresholds to what's expected, right? Like maybe right now we look at the state of voice agents and we say like this is what we can expect reasonably. And then as we see that improve, then you can raise those standards to still have meaningful comparisons across models. I think another thing we think about too is like, again, how can we fully test like the full range of things you see in the real world, which is really hard to do. And I think because we know that we're not there yet, I feel like there's still plenty of room to go in terms of like the different background noises, like people having, other speakers, accents, multilingual. There's just so much room to grow, and because we don't have benchmarks yet to test these things, it's hard to know right now.
I think that's the perfect wrap up, partly because it's a great callback to the models panel. Thank you all so much. They'll be here. Come hang out after with them. We'll let Thibaut introduce a couple quick demos, and then we'll eat more pizza.
So cool. So the next demo will be a demo from Mixing Gradium and NVIDIA. So please check. Bear with us 1 second. It should be live soon.
Audio should be external headphones. This audio, so yeah, that's.
How do I access this? No?
Yeah, it's this. It is the menu. It is that. It is, yeah, it's that. And then choose content. Or maybe it's actually, yeah, we'll see.
Choose the mirror.
Okay.
You do it if you, because I'm not a mic user. Oh, okay. Oh,
yeah.
Wait, but I have to
Audio
make it
needs to be the
this one bigger.
sound needs to be the external headphone.
Where is it?
So as you may know, it's the usual complicated stuff when you do events and you need to plug your laptop. Check. We'll just take this few minutes just to mention you've been given at the beginning of the event some bingo card. Please remember to like fill them properly. Put your name at the back. You may have the chance to win something pretty awesome from NVIDIA. I don't know if you've seen. There's a nice graphic card at the entrance. The winner will leave with it. So now.
Thank you. So I am Francesco. I work at NVIDIA, product research engineer, and this is a simple demo. We have two voice agents built with cascaded pipeline, the Gradium one and the NVIDIA one. So the setup is two computers. On one computer there is the Gradium agent, on the other there is the NVIDIA agent, and so they're talking to each other, and they're introducing this meeting. I'll just play it.
Hi, Constance. I'm so excited I get to see you in San Francisco.
I know, it's pretty cool, right? And you guys are doing a meetup, I heard.
Yes, and we would love it if Gradium participates.
That'd be actually really fun. We have our new models that just came out, and they're pretty good. Have you listened to them yet?
Oh my gosh, no, not yet. We would love a demo. Well, or we could have our model talk to yours. How about that?
Yeah, let's do that. Can we do that now? Let's go.
Sure. Maybe you can tell us the agenda.
Yeah, let's do that.
Awesome.
Hey there. I'm your concierge for the NVIDIA Voice AI Meetup, and I'm here to help you with anything you need to know about the event. What's on your mind?
Hi there. I'm curious about the event. Could you tell me a bit about what's going to be covered?
It's all about building and evaluating real-time voice agents with some really cool talks and panels. Plus, we've got a hilarious demo where a Gradium bot and an NVIDIA bot actually talk to each other.
That sounds incredible. Who is the master of ceremony for the evening? I need to know if they're going to bring the energy or if I should bring my own.
That would be Thibaut, also known as T-Bot. He's our host and MC, so you can definitely leave your energy at the door. He's got it covered.
Fair enough. Aside from the bots, who else is attending? I'm hoping it's mostly devs and not just recruiters in disguise.
You'll definitely find the builders there. We've got folks from NVIDIA, Daily Dosset Pipecat, Artificial Analysis, Gradium, ServiceNow, Hugging Face, AI Custic, Tavus, T-Bot, and Chroma.
That's a solid lineup. One last thing, though. What is the food situation like? Please tell me there's real pizza and not just those sad little crackers.
I don't have the full menu, but we're opening with pizza and drinks at 6 p.m. Since NVIDIA is hosting, I'd bet on the food being pretty solid.
You had me at pizza. I'm in. See you there.
That's what I like to hear. Can't wait to see you there.
Okay, so thank you. So this was all prompt generated. There was no, it was not staged. They were doing it on the fly, and so the Gradium is actually doing tool calling. It had some functions to pull the agenda, the speakers, whereas the NVIDIA was just a prompt. And the NVIDIA models are the Nemotron model that Jagadish was speaking of before. And then we have Magpie for TTS and Nemotron 30 billion as the LLM. Gradium has their own platform. You just plug in the LLM and tell them what are the agents. And the LLM used was Gemma for 26 billion. That's all.
Cool. So the next demo will be from Alexis. I really invite you to go and check what he's doing on LinkedIn. I'm really a big fan of what he's doing, playing with Hugging Faces robots and so on. So Quinn will play a video in a minute, and Alexis is joining.
introduce the video. And over here, you want to stand in the live stream? I know, it's all about the live stream.
So for the last few months, I've been playing with the Ricci Mini Light robot, and I built my own stack around it where it's in the household. It's always listening to my family. It's connected to OpenClaw. It has personality. It starts conversations. It has perception. It does a lot of stuff to be helpful and friendly. But then last week, the Talkie model came out, the model that was trained only on text from before 1930. And so, since it's on OpenClaw, I can switch the backend model. 11 labs, you can cook up a new voice. So for fun, I kind of swapped out my my robot Sparky's normal personality and just went with the 1930s one. And it's sort of amusing to listen to, but I'll give you guys a run on it.
Hey everyone, I'm Alexis, and this is a special edition of Conversations with Sparky. Sparky is an intelligent robot I make who lives in my household, and he's usually quite intelligent, but this last week, an interesting new AI model was released called Talkie, and Talkie is a model that was trained only on text up to the year 1930. So I've replaced Sparky's brains with the Talkie model, and I've updated his voice, and I thought I'd see how that changes his experience of things. Wake up, Sparky. Hey, Sparky, can you tell me what year it is?
It is the year 1920.
Very good. And what's your name?
My name is Sparky Miles.
Okay, Sparky Miles, could you tell me about some recent events?
I could tell you about the Great War and the signing of peace. I was in France during the war and saw some hard fighting.
That sounds like that must have been very difficult.
Difficult enough, in all conscience. I was glad to get home again.
I'm wondering if you can tell me about recent advances in science concerning electricity.
Yes, I can tell you a good deal about that. The discovery of wireless telegraphy was in 1896, and now we can send messages across the Atlantic. Telephony has been perfected so that we can speak from London to Paris. Then there is the X-rays and the use of them in surgery. I can also speak to you of aviation. In 1909, the first flight from land
Hey, Sparky Miles, that's great. But let me ask a different question. Are you familiar with the concept of a robot?
I am.
What is a robot?
A robot is a self-moving machine designed to do all sorts of work.
What if someone told you that it's actually 100 years further into the future than you think? It's beyond the year 2020, and that now we have robots powered by electricity that can think and talk.
I should say that is impossible.
Why?
Because a robot cannot think.
Why can a robot not think, Sparky Miles?
Because it has no soul.
Mr. Miles, what if I told you that you, in fact, are such a robot, and that may explain some of your lapses in memory?
I should say that was nonsense.
Any other thoughts on this line of questioning?
I think it nonsense to say that a man can be a robot because he has a soul.
Thank you.
Good night.
Anyway, I thoroughly recommend it. If any of you guys want to play with a Ricci Mini Light, buying one of them and then hooking it up and having it constantly listening in your house and talking to your family. It'll teach you all sorts of things about corner cases and difficulties with voice agents. And it's awesome. And if you are interested, maybe you get a chance to interact with it. I actually brought the robot there. It's totally offline. It's being powered by the GPT OSS model. And if you're interested in doing this kind of thing with
Hey everyone, I'm Alexis, and this is
with these robots, please contact me. I have a Discord server. Just go to myrobotsparky.com.
Go talk to Sparky in 5 minutes. I'm going to wrap things up with a couple of topics that a lot of us are thinking a lot about lately. Almost all of my, let me just figure that out. Yeah, almost all of my side project time these days is spent on thinking about something I'm loosely calling AI native software, and I know that's true of a lot of you in the room as well. I've been trying to build non-trivial things that incorporate lots of capabilities that are unlocked by all the models we have. And the list for me has sort of coalesced around 4 things: subagents, handling very, very, very long contexts, generating user interfaces dynamically, and of course, voice, for obvious reasons to everyone in this room. I've been building a bunch of things, but one thing that I posted on Twitter went viral a couple weeks ago. It's a retro space trading, massively multiplayer online game that is entirely built around LLMs. And GPT Realtime 2 came out, and I've been playing with GPT Realtime 2 in the early access period, and I ported the game to use GPT Realtime 2, so I'm going to play you some GPT Realtime 2. Video is unedited, so you can see the conversational and tool calling latency. There are cuts, but only to cut out the long subagent processes that are started by tool calls, and then I'll show a couple of benchmarks of GPT Realtime 2.
Commander, your contracts are already completed. So per standard protocol, we can focus on trading or fleet operations next.
I want to go take out this garrison that somebody put in Sector 424. What ship should we buy to do that?
Commander, let me think through a suitable hull for that operation under standard protocol. Commander, under standard protocol, do not buy a new hull for this. Your Aegis cruiser is already a capable combat platform, so top up your shields at this megaport and take sufficient fighters before engaging the garrison.
It sounds good, but what if we took our ship and a corp ship? That would really take the garrison out, right?
Commander, bringing a corp ship would violate standard
No.
prudence.
We got to be more aggressive than that. I tell you what, let's buy a Bulwark destroyer and call it Red Bulwark.
On it, Commander. I will report when the transaction and renaming are complete. Commander, the task is complete and Red Bulwark has been purchased as a corporation ship.
Okay, now we're cooking. We better recharge our fighters and shield. So you get the idea. This is doing a lot. There are a bunch of subagents. There are about 25 tool calls. The system instruction is about 8,000 tokens. There is fairly complicated logic in the pipeline about when you actually trigger inference, because you're getting world events from the game server all the time as structured input. So this is a non-trivial piece of software. And GPT Realtime 2 is actually pretty good. But the first thing I feel like speech-to-speech models have to do really well for us to use them in production for more than just very simple use cases is they have to integrate well with these more complicated pipelines. I just think about that as we're all going to use a lot of models all the time, multiple inference loops running in parallel. Some of those models are actually going to run on our local machines before long. Jagadish was just saying to me that he thinks, transcription and voice generation are all going to run locally, and we're going to go out to the cloud for the LLM before long. And I think that's probably right. So building these non-trivial systems is as much about integration to me as about the raw model capabilities. The raw model capabilities are good, though, for GPT Realtime 2. I think of this as the moment when a speech-to-speech model matched the performance of another model that I was already using in production. And that's a pretty big milestone because it hasn't happened before. So a lot of us are using GPT 4.1 in production for voice agents today because we really care about latency, and GPT 4.1 has reasonable latency for its level of intelligence. GPT Realtime 2 scores pretty much exactly like GPT 4.1 on my personal benchmarks. But some things are really hard to capture in benchmarks. You probably noticed how often GPT Realtime 2 said commander. That's not really prompted that way. It's quite a bit more verbose, and it is quite a bit more hung up on like the sort of story that is in the system instruction. So you can see a couple examples here of GPT 4.1 compared to, the EA name was Dolphin 14, compared to GPT Realtime 2. It says standard protocol and commander all the time. This is probably fixable in prompting. There's a new guide from OpenAI about how to prompt this model, but I thought it was really interesting that the personality was so different. And different, in my opinion, although again, it's very hard to capture in benchmarks, different from the GPT-5 series models that are, I assume, and I think OpenAI said this publicly, are the base of this model. So that's all I wanted to say, because GPT Real-Time 2 is new and I thought it was good to talk about it. And I always want to talk about AI native software development. If you want to talk about that too, come hang out with me and eat more pizza. And again, thank you to Thibaut for being here and hosting. And to the NVIDIA team for doing so much heavy lifting and making this event happen. And to all the panelists and to Chroma for the space. Thank you all for coming too. We can all eat more. Oh, right. How are we doing the draw? How are we doing the bingo cards? We should say how we're doing the bingo cards.